In our last lesson, we talked about what redox reactions are, and we talked about how to assign oxidation numbers to determine what's oxidized and what's reduced. Today, we're going to talk about how to balance redox reactions, which is similar to balancing normal chemical reactions, but it's a little bit different because we need to make sure that the charges are balanced as well. So to balance redox reactions, we're going to use the half reaction method. So as I told you in the last video, a half reaction is either the oxidation or the reduction reaction. So writing those two separately, we can see how the electrons are transferred. So in the equation down here, we have aluminum plus Cu2 plus goes to aluminum 3 plus Cu. All right, so if we were just balancing equations like normal, we would look at this and say, okay, there's an aluminum on each side and there's a copper on each side. That seems reasonable. But our charges aren't balanced on the two sides, so that doesn't work. Okay, so we're going to write our two half reactions. So we have aluminum solid going to aluminum 3 plus 3 electrons. Okay, so this is our oxidation reaction because aluminum is losing electrons. Okay, and we know it lost 3 because we go from a charge of 0 or an oxidation state of 0 to plus 3. All right, so there were 3 electrons lost. All right, and then our other half reaction is going to be Cu2 plus 2 electrons goes to Cu solid. All right, and again, we went from plus 2 to 0. This is a reduction reaction, and it means that we gained electrons. So that copper ion took some electrons back and became just a neutral copper atom. Okay, so now this is where the writing the half reactions is important. So you can see that we gained 3 electrons, but we only lost 2. So that is not balanced. So we need to multiply these half reactions to get an equal number of electrons on either side so that they can cancel out. So basically we want every electron that's lost has to be given to another atom. Okay, so we need to multiply the aluminum reaction times 2 and the copper reaction times 3 in order to get 6 electrons transferred in both half reactions. So we add those together and we get 2 Al solid plus 3 Cu2 plus goes to 2 Al3 plus 3 Cu solid. Now this method works great if all you have are the 2 elements that are there, but in most redox reactions, or in a lot of them anyway, you have oxygen and hydrogen that are present in the reaction that don't necessarily reappear on, or don't appear on both sides of the equation. So we have these steps for balancing redox reactions in acidic solution, and I'm going to just go through the steps one by one for this particular problem here, and then we'll do it again for part B. So the first step is to write the 2 half reactions for the equation. So in order to do that, we're going to have to assign oxidation numbers so we can figure out what's oxidized and what's reduced. Right? So iodine, or I minus, is easy. That's just -1 because it's the charge. I'm going to skip over the chromate compound right now, or ion, and over here we have I2, right? That's all by itself. It has no charge, so each of those iodines has a 0 oxidation number, and the chromium 3 plus has a +3. Okay, so this takes us back to Cr2O7 2 minus. Right, so we have 2 chromiums. We do not know the oxidation number for those, and we have oxygen, 7 of them. So it's going to be 2x, because we have 2 chromiums, plus 7 times -2 equals a -2. So when we do the 7 times -2, that's going to be 14, -14. We add 14 to both sides. That'll give us -12 on the one side and 2x on the other. So 12 divided by 2 is 6. So both chromiums here have a +6 oxidation number. All right, so our first half reaction is I minus going to I2 plus 2 electrons, and we need to do, 2 I minuses because we come up with I2 at the end. So step 2 is to balance the elements other than hydrogen and oxygen. So that's what we're doing right now. So we have 2 I minus goes to I2 plus 2 electrons because each iodine lost 1 electron. And then for the next one we have Cr2O7 2 minus. So we have 2 chromiums and they go from +6 to +3. So each one of those chromiums gained 3 electrons. So it'll be plus 6 electrons goes to 2 Cr3 plus. Okay, now our top reaction is balanced, so that's easy. The bottom one is not, because we have these oxygens on the left that we don't have on the right. Okay, so our next step is to add water to balance out any oxygen that's in our equation. So we need to add 7 water molecules on this side. Okay, but now we have too many hydrogens, but I said this was an acidic solution, so we're going to add H pluses to balance out the hydrogen. All right, so our 7 water molecules have 14 hydrogens, so we'll do plus 14 H plus on this side over here. Okay, now we have 2 electrons in our top reaction and 6 in the bottom, so we need to multiply that top reaction times 3 in order to get the electrons equal on both sides. Okay, and now we cancel out our electrons. Nothing else cancels out because we only have H pluses and waters in this one reaction here. Add them together, and then that gives us our balanced half reaction. And you can go back and double check that everything is balanced. You should have an equal number of all of your elements, and your charge to be balanced on both sides. Okay, so I'm actually going to have you pause the video at this point and try to do this one yourself. At the very least, you should be able to write the 2 half reactions and balance out, or balance the non-oxygen and hydrogen atoms first, and then add your electrons. And then if you can go the whole way through, absolutely do that. But pause now and go as far as you can, and then replay, and I'll go through the problem again. Okay, so hopefully you've come up with this as your 2 half reactions, the Fe2 plus going to Fe3 plus 1 electron. Okay, and then for the second one we have iO3 minus. Okay, so hopefully you figured out that the oxidation number for iodine in this case, since it's bonded to oxygen, is going to be plus 5. And then on this side it's 0. All right, and we have 2 of them, so it's gaining 5 electrons in for each one, so it's going to be 2 iO3 minus plus 10 electrons goes to I2 solid. Right, and now we need to add 6 waters to the right side of the equation to balance out the 6 oxygens that are over here. And then we'll need 12 H pluses to balance out our hydrogens. Okay, so now we've got 1 electron transferred in the top reaction and 10 transferred in the bottom reaction, so we need to multiply the top one times 10, and then cancel out our electrons when we add the 2 equations together, and and then this should be your final balanced redox equation here. Okay, so we will practice lots of these in Mastering Chemistry. I think they're kind of fun once you get used to them. You can start with practicing using the list of steps that are on the previous slide and that are in your notes, but eventually I will not give you those steps on the test, so eventually you need to be able to do that on your own without the steps in front of you.